problem was posted a long time ago, but I stumbled across it and decided to see if we could give it an answer. So you're given the equations of three parallel lines, told that you can create an equilateral triangle that has each of its vertices on one of these three parallel lines, on each of three parallel lines. And we're trying to find the length of one of the sides of that equilateral triangle. Now it turns out that we're going to, well, here's the equations rewritten with y equals, and we'll see that comes into play in a second. We're going to be using this idea right here. If you pick a point and want to rotate it some number of degrees about the origin, and it's convenient that one of these three lines passes through the origin. If it didn't, this problem would be much more difficult. But we're going to rotate this point, any point on this line, 60 degrees. And we're going to take a side trip to see where this formula comes from and what's actually happening. So here's a circle centered at the origin. We pick this point out here, any point. We're going to just be in the first quadrant. So the coordinates of that point are this distance right here, the radius of the circle, times the cosine of alpha, where alpha is this angle made with the positive x-axis, comma r sine theta. And then this purple angle is the angle of rotation. So you can see if I rotate that point, it stays on that circle. And if I rotate to 60 degrees, I will have an equilateral triangle because the two radii are equal. The purple angle here, theta, is 60. The base angles have to be congruent, and they have to add up to 120, so they have to each be 60. So we've got an equilateral triangle. Okay, if I set this alpha equal to 30 degrees, I get something like this. Now, where did the rotation formula come from? This is your image right here, r cosine of the sum of the two angles, comma r sine of the sum of the two angles. If you actually expand cosine of theta plus alpha using the trig identity, and same for the sine, you will get the formula that we saw on the whiteboard back on Wyzant, something that looks like this. This doesn't have to be 60, it can be any angle, but we're going to rotate 60 degrees, okay? And now you're going to see why. Okay, so let me hide this. Go to here. There's your three parallel lines. We're going to pick a point on the bottom line here and rotate it 60 degrees and see what happens. So here's M1. I just picked an x coordinate of 3. If I plug that into the equation for this line, the y coordinate is radical 3 over 3. If I plug these coordinates into this rotate formula, I get this point N1. And if I join these points, I have an equilateral triangle. If I pick another point on this bottom line and rotate it 60 degrees, I get another equilateral triangle. And I'll do one more. There's yet another equilateral triangle. Watch what happens if we draw a line through all those three, n sub 1, m sub 2, n sub 3. They're all on the line x equals 1. So we want to find this point of intersection right here. When x is 1, what's the y coordinate of that point? And then that will also create an equilateral triangle. We just don't know what the pre-image was. We'll see how to find that in a second. But the distance from A to this point is going to be the length of the side of the equilateral triangle. So let's go to board 2. Here's the first m sub 1. We saw that was 3, comma, square root of 3 over 3, because I plugged 3 into this equation right here. And the image is using the rotation formula. I'll put 3 in for x and radical 3 over 3 in for y. And I get, that's the coordinate of n sub 1 right there. Those are the coordinates of n sub 1. And in general, this is why the x coordinates of all those n images is 1. Because no matter what x is, this is the y value right here, radical 3 over 3, comma, times the quantity x minus 2, again from this equation. If I simplify that using cosine of 60, sine of 60, I always get a result of 1 because the x's cancel out. Okay, so here's what we've got. We've rotated 3 different points on this bottom line about the origin. A is 0, 0. And we want to find out what the coordinate, y coordinate is for this point right here. Oh, well, let's go back here and increment this one more time. There it is, 1, 3, radical 3. And the distance between those A and B is the distance formula, 2 radical 7. There's your answer right there. And if you had to find out the point on this bottom line that created the equilateral triangle, you could do that. We're going to see that in a second. Okay, so here's how we determine the 3 radical 3. Because we put 1 into this equation right here. So this is B 1, 3 radical 3. The distance between A and B is, as we saw on Desmos, 2 radical 7. We say that's the answer to the problem. Let's look at one more picture here. How can we find this point that completes the equilateral triangle? Well, the equation of this circle is x squared plus y squared equals the radius squared, which is this distance, 2 radical 7 squared, 28. We want to find the point of intersection of that circle with this line, radical 3 over 3 times x minus 2. Here's the work. You do get x equals 5 or x equals -4. For the x coordinates of the points of intersection, so way down here somewhere, this line also intersects at -4. But if you plug 5 in for x into this equation right here, 5 minus 2 is 3. 3 times radical 3 over 3 is radical 3. So, and you could calculate the distance from here to here, and I'll bet it's 2 radical 7. Because it's the square root of 5 squared is 25 plus radical 3 squared, square root of 28, 2 radical 7. And you could also do this distance right here. Find out that it is also 2 radical 7. Okay. Okay, there you go. Hope that helped if anyone watches this video. And if you have any questions, post a comment.